In pre-processing steps, when I say pre-processing, we will be doing some kind of data cleansing, or we will try to correlate with attributes and try to identify whether all the features that are present in the data set are relevant to our work. And also we will try to check for missing values. We will treat outliers. All these things we will do in the data pre-processing. So once you do the data pre-processing, your features are ready to be ready for work. So this feature can be given to the model building or any one of the machine learning algorithm. Based on what is your expected outcome, you can give your develop your machine learning algorithm. Okay. So this is what is actually called as training phase. Basically, your machine learning model has two phases. One is the training phase, the other one is the testing phase or the prediction phase. So in training phase, we will have the past data and we will do the cleansing or the pre-processing, everything. Do the feature engineering, that is prepare the feature that are required for our machine learning algorithm or to work with our machine learning algorithm. Then we will train our algorithm to work for this particular data. So once you train your algorithm to work for this data, your model is ready to go. So now when you get a new data, when you get some kind of test data, this data should again follow the same step of feature engineering. Like you have to do data pre-processing, then you have to perform feature engineering, and you have to give it to the learned model. So this learned model will try to access what kind of information is available in the feature attribute and will make a prediction. So it can be a prediction, it can be a regression, or it can be a similarity analysis as well. Basically, machine learning deals with three different popular types of learning methods. One is called as supervised, another one is called as unsupervised, and the last one is called as reinforcement learning. In supervised learning, you will be given, along with your feature attributes, a label data. So this label we normally call as targets or as class labels. So with the help of this class labels and the features, we will be training our model. So basically your supervised learning algorithm is of two types. One is classification model, the other one is regression model. So according to your target data, if your target data is a categorical discrete data, then the task will be called as a classification problem. Whereas if your target data is going to be a continuous numerical value, then we call the task as a regression model. Okay. So each and every task will follow different machine learning algorithms. Based on the problem in hand, based on the data set you have with you, you have to identify a appropriate machine learning algorithm. Then coming to unsupervised learning, here you won't be given any targets or class labels. So the data will be unlabeled. You will have only features with you. With the help of features, now your work is to identify patterns or similarities so that you can group together the data. So ultimately in all these things, we are trying to make some kind of grouping. Okay. So here, with the help of unlabeled data, I can either perform association rule mining or clustering. So based on the relationship between the variables or between the features present in my data, I can either perform association or clustering. Coming to reinforcement learning, this is one of the learning technique which is popularly used in almost all the AI models. This learning technique works based on feedback or reward. So you will be giving the input to the agent. The agent will check the environment in which it is working on. So based on the environment situations and conditions, the agent will send its feedback, and based on that, your agent will make a best action. So this is how your algorithm will be trained in reinforcement learning. Finally, you will be getting an outcome. So any one of the three learning strategies you can follow when you try to build your model. So how to choose your learning strategy? It all depends on the data you have. So as I already told you, if you have a label data, that is if you have target information or class labels, then you can go with supervised. So in supervised, again, you have to identify whether you're going to work with classification or with regression. So how to check whether I'm going to work with classification or regression? So if your class label is a discrete data or a categorical data, for example, I want to classify between cats and dogs. So here the class label will be either cat or dog. So this is a discrete data or a categorical information, or finding gender among a group of people. So all these things are some discrete information. So whenever your task is to identify a discrete data, then try to go with classification problem. So when your task is to work with a continuous data, for example, forecasting weather for a particular period. Similarly, identifying predicting housing prices in a particular area or a zone. So all this will have the class labels as a continuous information or continuous data, numerical data. So then you have to go with regression based algorithms. So choosing the correct algorithm is the first step in developing any model. Similarly, if you're not having a class label, or if your work is only to identify patterns, something like that, then you can work with your unsupervised learning algorithm or your association rule mining algorithm itself. For example, analyzing a satellite information or analyzing the galaxy information. You will have multiple stars, and we may not know what is the name of each and every constellation, or each and every name of each star is. So if I want to I group them according to some kind of patterns, then I can go with clustering information. The same way, when your work is not only to label the data or do only predictions or finding the similarity, but your work is going to do something further along with your prediction and finding the similarity, like based on the prediction you made, you're going to do some kind of inference. Then you can go with your reinforcement learning. So based on the rewards or the feedbacks you have received, you will be making a best action. For example, a self-driving cars. So you can have several image sensors in your car. So those image sensors can capture the objects before your that are present before your car, or any obstacle before your car. Okay. So your machine learning algorithm or your supervised learning algorithm will try to classify what that object is. But in reinforcement learning, you will be taught, or your algorithm will be taught, according to that object, what decision I need to make. So this is the difference between your supervised learning, unsupervised learning, and reinforcement learning. So taking supervised learning problem, today we are going to see a very simple supervised learning problem. So before going to any supervised learning problem based on neural network, we need to understand some basic concepts related to supervised learning. Okay. So what we are going to actually, when I say I'm going to group data according to the class information, so what I am going to do, I'm going to draw a decision boundary. So a decision boundary will split my data into two different groups. If it is a binary classification problem. So when I say binary classification, it's a two-class problem. Okay. So if you see this diagram, here I have data represented as plus and data represented as minus. So my task is to identify a decision boundary. So this is what is my work. Okay. So given features x1 and x2, and given class labels, the class labels are, so all x1 comes under plus 1 and or all x2 comes under minus 1. So or else any data which is greater than 0 can be classified as x1, and any data which gets a class label as less than 0 can be classified as your x2. Okay. So now my work is to draw a decision boundary or a decision function. Okay. So since this is a linear regression, so I can draw a simple line. So you can remember the line equation y is equal to mx plus c. So we are going to use the same function to draw our decision boundary over here. So if you see, the function dx resembles your line drawing equation. So it's y is equal to mx plus c. Here, w naught is the bias or the intercept, and mx is the value, where w1 is the weight and w2 is the weight with respect to x1 and x2. Okay. So in linear regression, basically with the help of sign information, we will be identifying in which group the data need to be classified into. So next is logistic regression. So one of the difference between your linear regression and logistic regression is, in linear regression, you will use the sign information to identify in which group the data needs to be placed on. Whereas in logistic regression, it is predicted with the help of the probability of the positive classes. We will try to identify the distance of the data with respect to the line and try to identify the positive probability of in which line this particular data can, or in which group this data can fall in. So that's the only difference between your linear regression and logistic regression. So based on probability, we will decide on where my data needs to be grouped in. So these are the two major algorithms which you need to know when you start working with either a machine learning problem or a deep learning problem, because this forms the basis for almost all your deep learning models as well. So now coming to the next problem. Again, I have a again, I'm going to have two features only with two classes. Here, if you see the data, how it has been placed. So here, if you see, all the pluses are accumulated in the middle and all minus data are accumulated in the border or in the outer boundary of plus. So how to solve this problem? How am I going to draw a decision boundary? So if you take your linear regression and your logistic regression problem, if you see, both of them are like linearly separable. That is, you will be able to separate one feature from the other feature in linear terms. Whereas if you consider this problem, it is a non-linear separable problem. Here, with a single decision boundary, I won't be able to make any decision on which group my feature will fall under. Similar problems you can see. So this is another problem. Again here, blue dots are accumulated in the middle and orange dots are accumulated as a circle. So here, it's like a four quadrant. In each quadrant, you have different data. Again, all these are two class problems only. The only difference is I cannot make a decision boundary, or I cannot separate these two things, these problems with the help of a single line. So this is where we have to check, or where we are forced to move from linear regression and the logistic regression algorithms. So one of the possible solution is constructing different lines, so which helps in separating my data, or which helps in separating the features. So here, if you see, towards the left, I can draw a line. Similarly, towards the line can be called as Z1 of X. Again, I'm going to use the same simple line drawing equation, whichever I have discussed in my logistic regression problem. Okay. So then Z2 of X will, I'm drawing a line with respect to right side of the data, and with respect to top of the data, I'm drawing a line, say Z3 of X. So now I can simplify my algorithm as Zi equal to sigma of W0 comma I plus W1 comma I X1. So with respect to each and every data point, I need to analyze the weight information as well as the bias information. Okay. So this is how I will be constructing the lines. So how am I going to merge all these three lines? Because now my lines are separate, I have three different separated lines. So now only when I merge all these three lines, I will be able to classify this into two different groups. So that is my next work. So my algorithm here, A of x, is going to be a combination of my Z1x, Z2x, and Z3x. Okay. So this is very simple. So initially, I am drawing three lines. I'm constructing three lines, Z1 of x, Z2 of x, Z3 of x, with respect to the corresponding data. Okay. So for each and every data point present in that corresponding location, I am constructing the lines which acts as a boundary between minus feature and the plus feature. Okay. So here Z1 of x, Z2 of x, and Z3 of x will act like decision boundaries between minus features and the plus features. Now, considering this lines as data points now, we are constructing our final algorithm. Basically, this is sum of product method. Okay. So here again, I will be giving that Z1 of x in place of x1, Z2 of x in place of x2, and Z3 of x in place of x2. Now here, if you see, I am extending this to a 3 class. So now, since I have three lines here, three different data features are being identified. Okay. From the three features, initially I started with two features. Now I am extending this two-dimensional or two features into a three-dimensional space, and then I'm planning to find out the class labels. Okay. So when I try to represent this in a computational graph, the computational graph will look like this. Initially, I had two features, say x1 and x2. Okay. So this x1 feature and x2 feature you have seen here, right? So it has been mapped to my Z1, Z2, and Z3. Similarly, my x2 is also mapped to my Z1, Z2, and Z3. Finally, from this information, from Z1, Z2, and Z3, I am making a prediction. So this is what is called as a computation graph. Initially, we try to draw the boundaries. So we identify the boundary equations. With the help of the boundary equation, we computed our algorithm. Then we are converting our algorithm to a diagrammatic representation called as computation graph. Okay. So here, if you see, the computed variables x1, x2, z1, z2, z3 are useful in performing the computation or useful in identifying the outcome A. So these are called as computed variables. Okay. And also you can see x1 and x2 is your z1 is dependent on x1 and x2. Similarly, z2 is dependent on x1 and x2. z3 is dependent on x1 and x2. So this is called as the edges in your computation graph is normally called as dependencies. Okay. So this computation graph, if you see, it resembles a simple neural network, or it can be also called as a perceptron. If it has multiple layers, we can call it as a multi-layer perceptron. So coming to from machine learning, now we are coming into the concept of brain-inspired machine learning. So what is brain-inspired machine learning? So your algorithm is now able to learn from the concepts given to it. Okay? So now my work is to make this algorithm work similar to how a human brain works. Okay? So there are two popular brain-inspired machine learning algorithms available. One is spiking method, the other one is neural network model. So we will see with neural network models today. So how your biological neurons or similar to your artificial neurons that will be available in your neural network. So we initially constructed a computation graph for a multi-layer perceptron, which is nothing but a simple artificial neural network. So it has inputs. The inputs were given to make a decision and output, and you had a layer which computed Z1, Z2 and Z3, which helped in identifying or which helped in deciding on your final outcome. So if you see your human neuron, so the neuron has dendrites and it will have a nucleus. The dendrites will carry the impulses into the nucleus and towards the cell body. Okay, so these impulses will be activated and will be useful to make an action. So same way in your artificial neuron, the X1, X0, X1, X2 or inputs, these are all sent through the axons. Okay, so here we will be having the weight informations W0, W1 and W2, which transfers, which helps in activating this input, and it helps in making a decision on what to be done with this particular input. Okay, and it will allow us to make the corresponding outcome. So some of the popular artificial neural networks available are perceptrons, multi-layer perceptrons, backpropagation neural networks, Hopfield neural networks, radial basis function networks. So when I say MLP, so this is how your multi-layer perceptron will look like. Here if you see X1 and X2 are input, and Z1, Z2, Z3 is the first hidden layer, which is given as input to the second hidden layer H1 and H2, and the inputs are activated in these two hidden layers with the help of weight information and bias information, and finally it has been used to predict your outcome. So again in MLP we can see two types. One is called as a feed-forward neural network. Okay. So here if you see X1 and X2 are the inputs, and alpha and beta are nothing but the weights that are associated with the inputs. So weights are nothing but what is the importance we will be having for that particular data or feature at that particular point. Okay. For example, if some heavy wind is blowing, okay, and I feel that some dust particles are coming, what will my brain immediately instinct to close my eyes? So this weight is something like based on the force my mind is calculation for the dust particle, it is making me to close my eyes. So my action or my output is closing the eye. Okay. So the force I am calculating for that particular dust particle is nothing but the weight over here. Okay. The input is through eye. So eye is the input over here. Okay. Similarly, with the help of this weight, your input will be activated, whether to close your eye or keep your eye open. So based on the wind speed, based on the size of the particle, you will be forced to close your eyes. So that's what is actually happening in your neural network as well. Okay. So finally, all these things will be given to the summation operator, and you will be predicted with it will be given to a activation function, a sigmoidal activation function, and you can get your final outcome. So the purpose of your activation functions is to determine the output of any neural network. Basically, your activation functions will be getting attached to each and every neuron in your network, and it helps in determining whether this particular neuron will play a major role in finding or in predicting the outcome or not. Okay. So this helps in relevant model prediction. Okay. So this is a major purpose of activation function. So activation function is one of the major component in any neural network. Similarly, when we talk about weights, we have to see one more thing called as learning rate. So learning rate is nothing but the amount that the weight is updated during the training. For example, the example which I have given you, maybe when I was a small kid, when heavy wind blowed, I may not have learned to close my eyes. I would have kept my eyes open, and that stone particle might have entered, that dust particle might have entered my eyes. So slowly, I would have learned that when there is a heavy wind and where there is lots and lots of dust particles around me, I have to either close my eye or I have to protect my eye with some eyewear or something like that. So this is what is your learning rate. So basically, your learning rate is like a step size for your weight updation. Okay? So you're updating your weight based on the learning rates. So coming to backpropagation neural network, here we have to see one more term called as gradient descent in here. So when we talk about activation function and learning rate, how this learning rate gets updated, how it will be updated in a step size information. All these things will be determined with the help of an algorithm called as gradient descent. This is nothing but a first order iterative optimization algorithm which helps in finding the local minimum for a differential function. Okay. So all your weight calculations will be like a derivative function. So in your forward propagation, when we talk about gradient descent, it will work with respect to the weight value or with respect to the neuron present in it. Okay. So, and your weight will be updated based on the gradient descendant value, based on the learning rate. Okay. So, this is how it works in forward propagation or in a simple feed forward neural network. Okay. So, the reason why we are including this gradient descendant is to reduce the total error in. So coming back to your backpropagation neural network. So in backpropagation neural network, so in addition to the feed forward, here if you see the weights are updated in a feed forward manner and activated to get your outcome. So now here what happens is once you get your outcome, you will be calculating the error rate or the loss information. Okay. So each and every classification problem will have a different loss function. Regression problem will have a different loss function. Similarly, your unsupervised algorithm will have a different loss function. So each and every model will have a separate different loss functions. Okay. So based on the loss function, you will be making your decision whether you have to retrain your model or not. Okay. So in feed forward neural network, you will make the decision of retraining your model. Whereas in backpropagation neural network, your model will train or retrain itself, or it will adjust the weight factors by propagating the error backwards with the help of a second order derivative. This is called a stochastic gradient descendant. Okay. So here it's again an optimization algorithm which back updates the error in a backpropagated manner. So here the input to the previous layer will be informed about the error, and again the weight will be updated in that layer. Again, if it is layer 2, now this updated weights will be given back to the layer 1, where the weights will be re-updated and it will go back to the original input layer. Likewise, the error will be back propagated and the weights will be updated. So this is what is your backpropagation neural network. So if you see the gradient descendant for backpropagation, it's basically a derivative of the error with respect to that layer's output. So for each and every layer, we know that each and every layer is a connected layer. So the output of that layer will make a decision on the error function here. Okay. So basically, you in backward propagation, this gradient descendant is nothing but the derivative of the error with respect to that layer's output. Whereas in terms of your feed forward, it is used to modify some of the parameters in the network. Okay. So that's a major difference between gradient descent used in your feed forward network and in your backpropagation neural network. So here, every time the error will be backpropagated and your weights will be adjusted with respect to that layer. So this is a very simple introduction to artificial neural networks. Before going to deep learning, I want you to try with or play around with artificial neural networks yourself. So this is a website which takes you to, or which has a inbuilt neural network built in it, and it gives you an option to add more, or remove features, and also it helps in modifying the learning rates, the activation functions, and other things. Okay, and also it helps in modifying your hidden layers and the number of neurons in the layers, and you will be able to identify the purpose of each and every parameter here. The parameter in the sense, the learning rate, the activation function, the regularization function, the number of hidden layers, the number of neurons in each layer, all those things you can check. Are you able to see this tool? It's called as playground.tensorflow.org. It's a website. Is it visible? Is the tool visible?
Not yet. No.
Is it visible now?
Yeah. Now it is visible.
So I will give the link in the chat box. You can also open and try yourself. I'll tell you how to work with this. So basically, this tool, if you're a very beginner to this, helps in identifying the importance of learning rate, activation functions for each and every category of your problem. Okay. So initially, I'm going to take simple two features. Okay. So I'm going to choose a problem, a classification problem. Okay. So the learning rate, and one more thing, your learning rate can be between any value from 0.0 to 1.0. So I'm making it 0.03. Okay. And we have different activation functions. The traditional ones are sigmoidal, tanh, and linear. And the modern activation function is ReLU. In sigmoidal activation function and tanh activation functions, they can be used, they cannot be used with multi-layers. That is one of the drawback in sigmoidal and tanh activation functions. And sigmoidal activation function gives very good results for classification problems. Okay. So it your accuracy reduce when you use your sigmoidal and tanh activation functions for a multi-layer model due to vanishing gradient problem. Okay. That is, the weights will not get updated properly. It will stay in 0 and it won't get updated. This is called as vanishing gradient problem. Okay. Whereas ReLU is one of the modern activation function. The purpose of ReLU, the main reason for inventing ReLU is to work with multiple layers, and it basically overcomes the vanishing gradient problem, and it helps in making your model learn faster, and it gives better performance. And again, making a choice for your activation problem function depends on the data and the problem type you are working on. We will see that also now. Okay. So I've already explained you what a learning rate is, right? So it's basically the amount that the weight will be updated during training. Okay. So we'll start with a simple classification problem. If you see this, so with a learning rate of 0.01, I'm taking. For tanh, I'm say taking. So epochs is the number of iterations it will be executing for. So here I have only 2 features. If you want, you can include more number of features also. Like this, I can include any number of features. Okay. So basically, these are all some noises I'm including here. Okay. So similarly, if I want to include the number of increase the number of neurons in my hidden layer, I can increase. Always remember the number of neurons in the hidden layers should not be less than your input. Okay. If you're directly connecting your input to hidden layer 1, make sure that you don't keep it minimum than the input layer. Okay. Because when you do the mapping, if you see all the inputs are mapped to the neurons. So when you do the mapping, it will create kind of overlapping, lots of overlapping if you have reduced number of neurons, which will obviously affect the accuracy or the performance of your model. And also, if possible, try to keep it in multiples of 8, like 8, 16, 32, like that. You try to keep it in multiples of 8. Okay. So the output, I'm going to get 2 classes over here. Okay. With the 4 features, I'm going to predict only 2 classes here. Okay. So now I'm going to run this. So my workers, if you see here, test loss and training loss are calculated. So it's trying to draw a boundary between the 2 different class features or the 2 different classes. Okay. So whatever feature comes, it should be mapped to which feature or which class. That's what this problem is doing, or this model is trying to do. Okay. So when my training loss and test loss is like this, see my model is. If you see it took nearly 300 epochs for the TANH activation function for the learning rate of 0.01 to achieve this. Okay. So now same thing, I'll try with sigmoidal. Okay. So we'll do the run it. Okay. So keep track of your test loss and training loss. See, your sigmoidal is taking more than 400 minutes even to get a training loss of 0.005. Okay. So in this place, TANH is playing a good role when compared to sigmoid. Okay. So now we will try to do the same thing with ReLU. So if you see, I am not modifying other parameters. This is what is called as hyperparameter fine tuning. Okay. See, when I used ReLU, if you see, with nearly 200 epochs itself, I'm able to come to 0.02. See, this is what is called as vanishing gradient. Below this, it is not able to go any further. The weight, even if the weight gets updated also, there is no point in using it. That this is the final test loss or the training loss I'm going to achieve. Okay. So I tried using all these 3 activation functions, and among these 3, I found TANH to be better when compared to sigmoid and ReLU. So now I'll try to improve the learning rate. Okay. So I'll start with TANH again. So if you see, I'm not modifying my input parameters, output parameters, or the hidden layers and neurons. So in your deep learning architecture or your neural network architecture, these 3 are called as parameters. Your inputs, the number of hidden layers, the number of neurons, and the number of outputs. This is called as parameters. Whereas your learning rate, activation function, epochs, regularization functions, and the regularization rates, all these can be called as hyperparameters. Normally, we try to fine tune the hyperparameters to achieve better accuracy. See, when my learning rate is 0.03, I am able to achieve a training loss of 0.01 at 79th epoch itself. So this is what you are supposed to do. You have to play around with your hyperparameters. You have to try fine-tuning your hyperparameters. And again, not all hyperparameter fine tuning will work for all kind of data. Okay, so each and every data will require different parameter fine tunings. Okay, so now trying with sigmoid for the same setup. So again, sigmoid is also giving less, it's taking more time. It requires more number of epochs. So now considering ReLU for this learning rate. Again, ReLU also required more than 100. So this is the one point I wanted to insist over here. So normally speaking, everyone will directly start trying to use ReLU activation function for all their problems. Okay. So first try to analyze your data. So in this case, this data required only a TANH problem which solve your purpose, or which try to improve the training loss and test loss in less number of epochs, or with less computational cost. So don't always start with a ReLU or a sigmoid. Try with all different activation functions and find out the suitable one. This helps in doing your result analysis. So when you convert this work to a paper, this is how you will be writing your result analysis. So what are the different activation functions you try to work with? How did you fine tune your hyperparameters, and how each and every hyperparameter played a role in making the prediction, or getting an improved prediction. All these things will help in improving the quality of your result analysis. Okay. So you can, I'll give you some 5 minutes time. Please try with, see if you see you have different types of data, spiral data, everything. Try to play around with it. So I'll give you some 5 minutes time. Try to play around with different learning rates and activation functions yourself, and let me know. Any doubts up to this? Sure, I will share the PPT. Please try to modify the number of input also, and also the number of new hidden layers also. If you want, you can add hidden layers also. You can add neurons to the hidden layers also. Okay. Similarly, you can add output parameters also. Try modifying all these things, and then try with the different parameters. Okay. Hyperparameters. Main thing, when you construct your, or when you design your model, you have to first fix your parameters. Basically, the parameters are input features, the number of hidden layers, the number of neurons in each hidden layer, and the output layers. Okay. Now, after fixing your parameters, play around with the hyperparameters. The hyperparameters are learning rates, activation function, regularization functions, regularization rate, and other things. You will be studying about regularization in deep learning optimization concept. Okay. So this tool can help you to work with regression problem also. Shall I continue? Yes, spiral data, right? And spiral data, you cannot keep it as a problem type as classification. You have to go with a regression, sorry. So it's again a classification type only. So here you can try increasing your learning rate for spiral data. Okay. So you can remove the hidden layer. So main thing is, if your data is not converging, if your spiral data is not converging, then first thing we have to do is try increasing the number of layers and then try to change your learning rate. So when you increase the number of hidden layers, uh, one thing we have to remember is keep your activation function as ReLU than a sigmoidal or tanh. Okay. So this is one thing we have to consider. So here it's not converging for even 500 epochs. So we can even try with a lesser learning rate, and we will try to increase the hidden layers. We can try to increase the features. Then we can try. See, the testing loss and training loss is remaining the same when I keep the learning rate as very less, even for more number of epochs. So it obviously tells me that this learning rate is not suitable. So I can increase the learning rate. See, it's trying to converge. But again, this learning rate is also not very suitable. So I can try to increase the learning rate. So this is how you will make a decision on which parameter, hyperparameter I need to fine tune. Okay. Likewise, you can try keeping on changing the parameters. So this learning rate also it didn't work. So I'm going to increase. Change the learning rate. So if you see for 0.01, the convergence is kind of good, or compared to the previous two learning rates. So again, see, it vanished. So I have to stop it again, change the learning rate, restart. The convergence is not happening again here also. Likewise, you can keep on trying to modify, and you can try to change your learning rate and the activation functions. Okay. So coming back to the presentation, please take your time to play around with this TensorFlow. You will not be able to understand each and every parameter within 5 to 10 minutes. You need to work on it. For each and every type of data, it will take some time. So now we completed with artificial neural networks. This is how what a feed-forward neural network will be, and what a back-propagation neural network will be. Then coming to the final layer, your deep learning architecture. So deep learning architecture is basically a subdomain of your neural network architecture. So deep learning is nothing but you're making your layers deeper. So how much deeper I need to make it, it again depends on the problem you have in hand. Basically, you need to understand the data you're working with before you choose your deep learning architecture. Okay? And then you have to identify the deepness of your deep learning architecture. Okay, so if you simply increase the deepness of the architecture, it won't give you a good result. You will require it will only improve the or it will only increase the computational cost. Okay, so every time you have to fix your parameters, play around with your hyperparameters, and then you have to train your model. Then only you will finally come to a conclusion why your data is behaving like this for this kind of architecture or for this kind of activation function or for this kind of learning rate. Because not each and every data will be similar, right? Each and every data will have its own pattern, will have its own convergence and other things. So first, to understand the data, we need to play around with different parameters and hyperparameters. Okay. So why deep learning? So one of the main fuel for deep learning is the big data. So when the data size becomes huge, the traditional machine learning algorithms or the neural network models convergence is becoming a problem. So when your data size becomes bigger, with the help of deep learning, we are able to design a model with improved accuracy and performance. Basically, your deep learning algorithm attempt to learn with the help of multiple levels of representation by using hierarchy of multiple layers. Okay. So tons of information helps in understanding and responding. So in simple terms, if I want to give you an example, for example, say my kid, she may be if she is at 3 years old, she may not know which is a cat and which is a chair, which is a dog, something like that. Okay, so she keeps on touching any object and she keeps on saying everything to be a cat. Myself, we can teach her saying that this is not a cat. Yes, this is a cat, like that. So we have to keep on teaching her, saying that maybe for 5 to 6 months or something like that. And I have to keep on telling her whenever she touches a chair or whenever she touches a table or something like that. This is a chair. This is a table. So these are the features of a chair. These see, this is how your cat looks like. This is not a cat, like this we can tell them and we can train them. Same thing is also happening in your deep learning also. Okay, so when you try to introduce more data, okay, so apart from cat, when I try to introduce a bottle, a chair, a table, say a door, a dog, a bird, something like that, and keep on increasing the data and making her understand that these are different from cat, so she will learn it. So same way only your deep learning also is working. So we are giving more positive samples and more negative samples and making my model understand and respond to what is a cat and what is not a cat. So this is what is happening in your deep learning as well. So some of the popular deep learning algorithms are fully connected neural networks, so which is nothing but your feed-forward or your multi-layer perceptrons. Then convolution neural networks. These are feed-forward networks with sparsely connected weight sharing facility, with or without weight sharing facility. Basically, this convolution neural networks will be used mainly for image classification or computer vision related tasks. And next is your recurrent neural networks. So this will work with the help of feedbacks. These are used for time series prediction. So next is your long short-term memory networks. This is actually an extension or enhancement of recurrent neural networks. So here, along with feedback, storage also will be included to get your predictions. Again, this is also used for time series prediction. In addition to it, we have deep Boltzmann machines, deep belief networks, and other things. So each and every neural network or each and every deep learning algorithm has its own purpose. Not all algorithms will be suitable for all data types. So some of the limitations of deep learning are, so one is we require huge training data set to work with deep learning. The second one is a popular problem called as data labeling. So data labeling is one of the work we also call it as annotation, image annotation or video annotation. We will be identifying, classifying or detecting the objects in a scene and try to label what that object is. This is one of the popular problem in computer vision tasks. For example, in a self-driving car. So I'm taking some images or videos with the help of sensors, and then I'm trying to identify what object is, and then I'm trying to label that object also. If I use my traditional machine learning algorithm, it gives a very good result in data labeling, whereas your deep learning model has some limitation in this domain. So before choosing your deep learning, before deciding on choosing for any deep learning algorithm, please make sure that whether your data requires deep learning or not. Okay? So that's one of the analysis we have to do before starting working with deep learning. Okay? So this is one of the deep neural network architecture. So here I have inputs and hidden layers. If you see, I have connections connected between input layer and the hidden layers. Okay? So each hidden layer will get the weight and the feature information, and it will be forwarded, feed forwarded to get my final output. So I'm increasing the depth of my layers. So major components we have already seen while we playing around with TensorFlow, playground.tensorflow, right? So I have to define the input nodes, the connections and the associated weights, which is nothing but the learning rate. And then it can be found out with the help of this formula. So this is nothing but your line equation. Then I have to fix a threshold. If it is a binary class problem or a multi-class problem, I have to fix thresholds for defining which class that problem will fall under to decide on the number of output nodes. Okay. Then I have to find out the bias information, and also I have to identify the activation function which I will be requiring for the deep neural network architecture. Okay. So coming to the implementation, so today we will be seeing a deep neural network with Keras library. Keras is one of a popular easy to use Python library which helps in developing and evaluating the deep learning models. Basically, Keras has several computation libraries like TensorFlow and Theano wrapped into it. Either I can go with the TensorFlow or Theano, and then I can work with Keras library to build my deep learning model. Okay. So what we will be doing is we will decide on the data set to work with. Then we will define and compile our deep neural network architecture. Then we can validate the results. So this is what we're going to do as part of implementation. So data sets I have already shared to you. It's the wine quality data set. Hope everyone is having it, right? So this data set, if you see, it has two different CSV files in it. One has information about the red wine samples. The other one has information about white wine samples. Okay. So the objective is to, now what we are going to do in today's work is, we are going to combine these two CSV files. Okay. And then based on the features present in it, we are going to predict which wine type will it be, whether it be a red wine or a white wine. So this is a binary class problem we are going to do. So the same same data set can be used for binary classification work, regression work as well. So if you see that UCI machine learning data set repository, they will give you for which and all, for which associated task this data set can be used. Today we are going to see a simple binary class problem, but you can use it for regression as well. And the number of instances will be 4,898. Okay. So it has nearly 12 features. Okay. So they are fixed acidity, volatile acidity, citric acid level, residual sugar level, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH level, sulfates, alcohol, and quality information. Okay. Based on these 12 attributes, I'm going to find out the type of the wine. Actually, if you see the data set which I have given to you, it will have only 12 feature information. Okay, the columns are the feature attributes. Okay, so the final one, the 13th attribute type is not there in your CSV file. You will see how to append this type information also to the CSV file. This is going to be going to act like the class label for this problem. Okay, so as I've already told you, this can be used for multi-class classification also. In multi-class classification, you can use the variable, say, quality. So for both red wine as well as white wine, not only determining the type of the wine, it helps in determining the quality of the wine also. The score will be between 0 to 10. So for this, we have to use a regression model. Okay, so regression based neural network we can define and can work with it. Okay. So after the session, you can try with this quality, considering quality as a class label, you can try that task also. Okay. So what are the main steps we are going to do is, first we are going to define the problem. So we have already defined the problem. So I have 11 feature attributes. I'm going to ignore the quality feature now. Okay, so I'm going to have 11 features and I'm going to predict the type of the wine. Okay, then I will do some kind of data analysis to check whether my data is proper to go with. This is to go with the preparation, okay, for preparing or for doing pre-processing of the work. So I need not include all the pre-processing steps like data cleansing, outlier detection, missing value analysis, everything before building my model. Instead of doing all these things, I can do some analysis and then I can go with the pre-processing. But in today's sessions, I'm going to skip this analysis and pre-processing due to time constraint. But always remember, do some data analysis, then do the data pre-processing. Don't simply go with all the pre-processing techniques without doing an analysis. Okay. So then I'm going to fix on the parameters for my neural network model. Then I'm going to fine tune the hyperparameters so that I can improve my model and evaluate the model and decide on the stopping criteria. Okay. With that, we can make a result analysis and we can improve the model. Okay. So this is what is the agenda for the implementation session. So any doubts in the theory? So I'll forward the link to the data sets. It's already been forwarded in your WhatsApp group. Okay, I'll forward it here as well. Just give me a minute. Thank you. So this is one data set. Please download both the data sets. To consume time, I will share the code also with you. Okay, so don't waste your time in typing the code now. Try to understand what we are doing. Okay, I'll give you the code as well now. Okay, so this is the link for the code. I will share the link in WhatsApp group as well. Please don't change anything in the code now. Later on, you make a copy of this notebook in your own drive and then you try to work with it. Okay. Is the Colab environment visible? So as I told you, this is going to be the steps involved in building the deep neural network today. So hope everyone might have worked with Google Colab, right? Google Colab is nothing but a cloud environment where you can execute your it has a inbuilt Jupyter notebook in it where you can execute your Python codes. Okay, so you have the option for choosing different runtimes or runtime environments also. You can even if I select if I go to runtime and select change runtime, so the hardware accelerator can be selected here. If I say none, it's the CPU version. If I select GPU or TPU, it helps you to work in GPU or TPU environment. Okay. Since the problem is small, I'm going to work with CPU environment itself. Again, I want to insist this also, don't always go with GPU. If your problem is simple, if you're in the learning phase, try with CPU itself. Until and unless you have a very big data set which involves huge memory, go with the GPU. Otherwise, your CPU itself is fine. Okay, because in Colab we have some limitations as well. Okay. With terms of the number of hours to run it and the size of the data set being used. So as a first step, we have already defined the problem. So we are going to use the wine quality data set. So this data set has two different, so this is a website where I have downloaded it. So if you see the data folder, you can see the two CSV files I have given you. It's a wine quality red.csv and wine quality white.csv file. Okay. So these are the two files we are going to use, and we are going to do a binary classification now with the help of the first 11 input variables. Okay, I'm going to ignore quality because only when I want to identify the quality of the data, I need to use this as an output variable. But now my objective is to determine the type of the wine. Okay, so I'm going to only fix with this variables. Okay. So before starting with your thing, you have to import before starting with doing the code, you have to import the required libraries. It's not mandate. It's not mandatory that you have to import all the libraries one in a single go. Okay, as and when you require a library, you can keep on including that particular library. Okay. So So pandas, NumPy or standard libraries. Pandas helps is used for working with the CSV files. NumPy is for doing the scientific calculations. Okay, and Matplotlib and Seaborn or libraries for plotting. And then sklearn is a library which helps to work with machine learning and deep learning algorithms. Okay, so all the models here are I'm going to extract from the Keras library. Okay, so here we are going to work with a simple sequential model. Okay, so for defining each and every dense layer, I need to include the corresponding library. Okay, so similarly, to drop out any variables required, I'm going to include a dropout library. I'll talk about dropout when we execute the program. Okay. And in order to split my data into training and testing, I'm going to use the sklearn model selection library. Okay. Similarly, Keras classifier wrapper I'm going to use. This nputils is a library which helps to convert your class labels to which helps in doing one-hot encoding of your class labels. Hope everyone know one-hot encoding, right? So one-hot encoding is nothing but you may have any kind of class labels with you. Converting them to zeros and ones or the corresponding discrete number information is what is called as one-hot encoding. Okay. So for doing that, I'm going to use nputils. Okay. And if I want to, while I do training and test split, if I instead of going with, right, in splitting your training and testing data, we have again several methods. We have holdout methods, k-fold validation, and other things. So, but today I'm going to use a holdout method where I will be splitting my training and test data to 75 and 25. If you want to use k-fold cross validation, you can go with k-fold library. Okay. Again, label encoder is also an additional requirement for your nputils. Okay. So today we are not going to use pipeline, so you can ignore it. Then the computation is going to work with the help of TensorFlow, okay, and not Theano today. Okay. To enable multiprocessing in a queue, I am importing this queue library as well. Okay. And sometimes in collab environment, when you use TensorFlow, it will throw some random errors. In order to overcome those random errors, I am using this tf.config.run functions eagerly. This is like a exception handler. So coming to the work, so now my first task is to read the data. Since I'm going to work on Google Colab, first I can either save my data in my drive and I can mount, or I can directly get my data from my local system also. Okay? So this code helps in getting the data from the local system. For doing this work only, I'm importing the IO library. Okay. So to work with the input output, I'm working with this. Okay. So I can choose the files over. So when you run this, if you see this button, this is called as the execute button. So if you are the first time user of Google Colab, I'll just show you one empty notebook. So this is how an empty notebook will look like. Okay, you can give a name to your notebook here, something like this. Okay, and this is the area where you can type the code and you can execute. You run it with the help of this button. And if I want to give any description, in addition to including comment line in my code, I can have a text box also. The text box gives the facility to give description about your code. Okay, you can even link any links here. You can embed objects also here. Okay, and this helps in giving description. This is how your untitled or your new notebook will look like. Okay. So coming back to the implementation. So here, if you see, once I execute the code, it will ask me to choose the file. So I can go and choose the file. So initially I'm taking wine quality red file. Okay. So it will be uploaded. So it will be uploaded in a temporary environment. Okay. The file name is wine quality -red. Okay. Now this file I'm going to read into my Python environment with the help of read_CSV. This read_CSV is available in the pandas library. Okay. So I've already renamed my pandas library as PD. So I'm going to assign it or store it in a variable called as red. Okay. The reason for using, I forgot to execute this. So first I have to, once you type this, you have to execute this. Now you can read. So the file has been read. So here I have mentioned separator equal to colon. The reason is if you open and see the file, in between each and every feature, there will be a colon given. Okay. So if you don't mention whether the separator as colon or whatever it may be, it will combine all the data and give it under a single feature attribute. Okay. So in order to split it, I am giving the separator information. So now similarly for white wine also, I am going to choose the file, upload the file. Okay. In a local temporary environment, I am uploading it. Okay. Once it is 100% done, to work with Python environment, I am reading the CSV file in a variable by name white. So now to check how my data is looking like. So red.head is used to get the head information or the top 5 features in your CSV file. Okay, top 5 records in your file. Okay, see, this is a feature: fixed acidity, volatile acidity, citric acid, residual sugar. All these are features. Okay, whereas this is the record number. Okay, so here I have, if you see, I have only 12 features. Similarly, for white also I can check. So now, similarly, just like identifying the head information to get the tail data, this will just before working with your data, I'm trying to check whether the data has been loaded properly or not. Okay. So for when I give tail, the last 5 data will be displayed. Okay. So I have nearly 4,897 records in white CSV. Okay. White wine CSV. So the last 5 records are getting displayed. Okay. So next is profiling or data analysis. So profiling is nothing but to get more insight of the data which we are working on. Shape will give the size of the data set. Column types will tell us about the information about the column, like what is the data type used to create this column and other things. Okay. And it gives we can use some describe is a function which used to give quantitative description about my data, like what is the count of the data, what is the min value in it, what is the max value in it, what is the mean value in it, median value in it, average value in it, all this information it will give. Okay. Similarly, for finding missing values also, I can use them. All these things I can do this analysis to decide on the pre-processing which I have to do. Okay. Similarly, outlier detection, all these things can be visualized as well. Okay. Today I'm not going to work on the visualization part because of time constraint. So checking the size of the white CSV file, see, it is having 4,890 data and 12 features. Okay, 4,898 rows and 12 columns. Okay, so then your column type information tells about the individual variable information. Okay, if I use the .info, info is the function for identifying the column type. See, it tells me what is the data type and how many non-nulls it has. All those information I'll be getting. If you see, I have nearly 11 float variable and one integer variable. All these things can help in determining whether your data set has a class label or not. All these information you can determine. Okay. Then coming to data description, basically this is almost like a univariate analysis only. Okay. So here you can even do the same thing with the help of charts like box chart, and also your histograms can, your scatter plots, all these things can be replaced with the help of a describe function. Okay. But instead of graphs, I'm just going to show you the describe function alone. So when I give describe, see, it will give the count information, mean information, standard deviation information. So min information, 25%, 50%, 75%, or the interquartile informations which you can get from a box plot. This information will tells you about the outliers. Okay. So we normally construct a box plot to identify the amount of outliers present in our data. So the interquartile information, the 25%, 50%, 75%, helps in determining whether my data set has an outlier or not. Okay. So coming to next part is to check whether it has missing values. So I can use is NA function or is null function. So for red data set, I'm going to check whether it has what is the missing value information. So overall it is showing. Okay. So here also overall it is showing. But analyzing this will be a little bit difficult. So in order to analyze it, what I can do is I can try to find the sum for the null values. Okay. So here if you see, my data is not having any noises. That's why it's giving, there is no null data. Already in data description also we have got this information. In data column type information, there is no null data. Okay. Same thing I can identify with the help of this also. Similarly, if I check for red also, I will be getting. Okay. Here I'm checking whether NA data is available or not. Again, it's also not available. Okay. So it shows that my data is not having any missing values. So I don't have to specifically do any missing value treatment or something like that. Okay. So by doing all this analysis, you can determine whether you can have to include a missing value treatment for your data or not. But always remember, most of the real-time data you work on will definitely have missing values and outliers. Okay. Since we are taking this from publicly available data sets, these data sets are for academic purpose or for research purpose. So almost all the real-time data will definitely have missing values and outliers. So you have to do it. But before doing it, make this analysis, which will help in deciding on what kind of missing value treatment I have to do, what kind of outlier and remedy I have to do, all those things, analysis you can do. Okay. Now, up to this point, if you see, I have two different CSV files. One is a white file, and one is called as white, and the other one is called as red CSV. Okay. So now what I'm going to do is I'm going to merge these two data, because my problem says that with the given data, I have to identify the type of my wine, whether it's a red wine or a white wine. Okay. So I'm merging all the data, and I'm going to insert a class label also, because if you see here, the attribute doesn't have the type information. Okay. Since I want to take this as a classification problem, I am manually going to include a column which will have the class information. Okay. So to start with, what I'm going to do is I'm going to include a column called as type. Okay. And in type, I'm going to assign a value 1. So initially I'm doing this for the red data set. Similarly, for white wine data set, I am going to include the same column type with value 0. Okay. So I'm inserting the class labels 1 and 0. Okay. Initially for the two different data sets. Okay. Now my next task is I have to append this two different data sets. So I'm simply going to append. So I'm going to use a new variable named wines. in which with red I'm going to append white. So the the data in my white wine CSV will be appended at the end of the red wine CSV file. Okay, so I'm simply ignoring the index. So when I execute, this will get created. So basically what I'm doing is, since I'm making this as a binary class problem, okay, I'm simply going to determine the wine type, whether it is a red wine or a white wine. I'm including a feature or a column by name type, which will act like my target variable or the class label. Okay. For all the values in the red CSV file, I'm assigning a value 1 for this column. Similarly, for all the records in my white CSV file, I'm assigning the value 0. Okay. So finally, I am appending these two files. Okay. I'm appending my white CSV file to the red CSV file, and my final file is being created. So this is a file which I am going to work on. So always lots and lots of pre-processing steps you will have to do depending upon the problem you have in hand. So again and again, don't think that I'm insisting it. Before starting to choose an algorithm, it's mandatory that we have to understand the data. Without understanding data, if we try to simply choose an algorithm, definitely we won't get good results. Okay. So now if you see, I have 13 feature attributes for this wine CSV file. Okay, I have included the type information also. Again, it's an integer variable. So I have two class labels now. So these are the 11 feature attributes I have. So now the count has also increased since I have appended the red CSV file with the white CSV file. Okay. So now I can again try to describe this wine CSV. So it gives again the count, all the information. So now the data set has been prepared to work with. Any doubts up to this? Okay. Now we can proceed with splitting the data sets into two divisions, because we have already seen, right, any machine learning problem will require two different sets of data, like training data and the testing data. Training data is used for building your model. Testing data is used to determine whether the model built is working correctly or not. Then we can test. We can give it to the real-time environment where they can work with new data. Okay. So in order to work with training, work with the train test splitter, we are importing the train test split from sklearn library. Okay. So then we are choosing from 1 to 11 features. I'm going to take it as X variable. So normally in machine learning, we will have two variable names X and Y. X will be the set of features, and Y will be the target variable. Okay. So all the features I am going to map in the variable by name X. Okay. And wine types I am going to ravel into the variable Y. Raveling is I'm going to give a layer, almost like doing a one-hot encoding only. Okay. Since I've already assigned it as 0 and 1, I don't have to manually do one-hot encoding. I'm simply raveling the data to Y. Okay. So here I have initially splitted the wine data set, which has the 13 columns to 11 columns in X variable and type the last one variable in the Y variable. Okay, so this is what I am doing here. iloc is used to subset your data. Okay, so this is a function which helps in subsetting your data sets. Okay. So the next step is splitting the data set for training and validation. Okay. So here, so for training, I will require the features. For testing, I will require some features. The corresponding class labels for training I have to get, and corresponding class labels for testing I have to get. Okay, then by using the train test split function, I'm going to split it here. For 75%, I'm going to give for testing and 25% for testing. Okay, so the random state I'm initializing as 0. The purpose of doing this random state is, so always, even if I do a shuffle when we try to build the model will shuffle the data. Even if the model shuffles the data, it should happen only within the 75%. Okay, and it should not miss the. It should not take the 25% allotted for testing data. Okay, so that's why we are assigning a random seed. So now comes the model building. So here we are going to build a sequential model. So I've already imported. Okay. So but just for you to understand, so these are the files we require for building the model. I'm giving this. Okay. Then sequential is a constructor which helps to build the model. So this is going to be a sequential neural network. Okay. So first dense layer I'm adding. So the first dense layer is going to be my input layer. Okay, so the input has a dimension 11, which will be mapped to the next dense layer, which has a 16 neurons. Okay, so this will be mapped to the next dense layer with the input with the number of 8 neurons. Okay, so here I'm using ReLU function only. Since it's a binary class problem, as I have told you, with the help of sigmoidal function itself, I can get good results. So I'm in the output. So this is my final dense layer. So this is my output layer. So I'm defining it with the help of sigmoidal activation function. Here, in addition to this, you can even include learning rates, optimizers, and other things. Okay. So next is model.out.shape. Since my data is more pure, I will be able to get more than 90% even with this activation function with this number of neurons itself. So I'm directly working with the default learning rate and the default optimizer. And then to get the summary of the model, I'm using that model.summary. Okay. So when I try to execute this, it will give me a brief summary of the model which I have created. Okay. See, this is the layer I have defined. So it has 3 layers: the input layer, the output layer, the hidden layers, and the output layer. Okay. So the input dimension is 11, and the hidden layers has dimensions, or the neuron number of neurons is 16 and 8, and the output is going to determine the type information, whether it's a red or a white one. Okay. So once you define your model, here you can add any number of layer. Okay, like this you can add by simply copying and pasting this. I can add any number of layers. Okay, so for each hidden layer I can include like this. Okay, so and if you want to change the values here, you can change. Finally, it will give me, when I do the compile, it will show me. So I have included one more layer, dense layer. So this parameter tells me the shape of the data. Okay. So this is how you can increase the depth of your neural network to make it a deep layer. So on this, compile is a function which helps in compiling your model or building your model. Here, the loss function I am choosing as binary cross entropy. Similarly, you can, since this is a binary problem, I am choosing binary cross entropy. If it is a multi-class problem, you can choose categorical cross entropy. Similarly, if it is a regression problem, you can choose minimum mean square error. Likewise, we have different loss functions for the different problem types. Okay. And the optimizer I'm going to use is Adam. Since it's a binary cross entropy problem, the metrics which I'm going to determine is the accuracy of the training model. Okay. So once you compile your model, we can fit the model. Okay. So initially I have designed a model, okay, without any prior input data. Okay, so now I'm going to fit my model for the input data. Okay, that's what is this fitting a model does. Okay, so here for the x train value and the y train value, I'm fitting my model. Okay, for the number of epochs and the batch size and all, I'm determining. So here number of epochs is the number of iterations. Okay, so batch size is a parameter which helps in identifying what will be the number of or a grouping of parameter, grouping of records which can be given in each, executed in each iteration. Okay, so verbose equal to what? This is a parameter which shows me the output. If I want to see at each epoch what is happening, I can keep verbose equal to 1, or if I can if I keep verbose equal to 0, this epoch information you will not be able to see. Okay. So when I fit the model, since I have kept verbose equal to 1, if you see, so the model will be starting to execute. So here if you see, the loss information is this and the accuracy is information is this. So for each epoch, it will try to run the 4872 records at a batch size. So since I have given batch size of 1, for 1 only it is executing. Basically, batch size helps in reducing the computational time. If you increase the batch size, it helps in reducing the computational time of your model building. See, initially, in the first epoch, the model started with an accuracy or ended with an accuracy of 92%. Then in the second epoch, it gave me 93%. So now it is increasing to 94%. If I try increasing the epoch number, I will be able to see the upcoming stages. And at one point of time, it will saturate, the accuracy will get saturated, and we can keep that as the stopping criteria, and we can save that model. So now this model is giving me an accuracy of 94 percentage. Okay. So now I can try doing different combinations. I can change the batch size to 20, and I'm going to increase the number of iterations, and I will check the same model. I'm not modifying my parameters. I'm just fine tuning this epochs and batch size here. See, it's running a bit faster. So when you increase the batch size, it helps in increasing the computation time of building your model. See, when I increase the batch size and the number of epochs, I'm able to get a improved accuracy. Okay. Same thing with the same thing. Now I've got 97%. Same thing I'm going to execute. So for 5 epochs, I'm able to get 97%. So like this, you can again and again try training with the same set of value and decide that your model is giving your proper value. Then you can save that model. Okay. So you should get the same values. Now to determine the accuracy, I can simply evaluate. So the accuracy is 97.74%.
So if I want to predict this value, I can predict. Now, if you want to further identify the validation accuracy also, you can take this Y predict, compare it with the Y test, okay, and then you can find out the percentage. It's like a if comparison. You can write your code and you can make a comparison. Okay. So the same model, like some of the changes what we can do to improve from 97% is because we know that the data is good. So what we can do is we can include some kind of standard scalars. These are all some data normalizers. You might have heard of min-max normalizer and standard scaling normalizers, right? We are going to scale the data. So basically scaling is making your mean, all the data's mean and closer to each other, and reducing the standard deviation. Okay. So here I've, instead of taking my raw data as from the CSV file, I'm doing a normalization. Okay. So then I'm building my model. And for this normalized data, I'm trying to fit my model. So this is to improve the accuracy I'm doing. I'm checking whether my accuracy can be improved. Yeah, see, definitely it's improving. So this normalization techniques are helpful in improving the accuracy. Okay. So like this, there are several methods which helps in improving your accuracy. So I can finally identify the training accuracy. Okay. So again, I can predict. And one more thing, after you predict, when you find the testing accuracy, make sure that it should not deviate much from your training accuracy. If it deviates much from your training accuracy, then that problem is called as overfitting. Okay. So some of the ways to avoid the overfitting are by doing feature selection. Okay. So feature selection is one further field of study which helps in reducing overfitting, improving accuracy, and reducing the training time. Okay. All these things also you can try to check. And so with this, we have come to the end of this session. Yes, code will be shared. I think I have already given the link for the code. You can create a copy of the notebook. Okay. So if you see, I have already shared that code. If you take this code, please don't directly start working with this code. Right click on it. You have an option to make a copy. Okay. Make a copy in your Google Drive, rename, and then work. Because everyone, if everyone tries to modify this code, definitely others will not be able to use it. No, I don't understand. This is a code actually. So this is the Python notebook, Jupyter notebook. Okay. So any doubts? So this is a simple deep neural network for binary class problem. Any questions?
Participants, if you have any questions, please you can ask.
Hello. Hello, madam.
Yes,
ma'am,
ma'am.
it's here.
I am trying to execute program in Colab. I have downloaded the file also, but when it is choosing file, nothing is happening. It is only circulating that cell is. It is not able to choose the file that wine quality file.
That file you have to download it in your local drive, ma'am.
Locally I have done it. Locally I have downloaded.
When you
Then I'm
choose
giving
your
that choose the file. It is not. It is circulating. That cell is always circulating. Nothing is happening. Means I am not assigned a TPU.
have you imported that this files, and then the same
Uh-huh.
code only you're doing, right? So when you click
yes.
on this choose files button, so
Ha,
when you click on this and if you click open, automatically it should work, ma'am.
but
Maybe give
that
some
cell,
time and then try
okay,
this.
okay. The
Okay,
cell is continually rotating. It is not showing. Okay. Means
maybe some
maybe,
network problems.
maybe, na? Okay, okay. Okay, ma'am. Thank
Yeah.
Hello.
Yes, ma'am.
Madam, if my data set is high dimensional and low sample size data, can I use deep learning techniques?
Ma'am, again, as I have told you, high dimensional in the sense, what do you mean by that? Like, is it a
My
video
data set is,
data?
no ma'am, it is gene expression data in bioinformatics.
Okay.
So the number of columns is very large, dimension is very high.
You mean the number of features are very high?
Yeah, number of features is very high.
Okay. And what kind of prediction you're going to make? Is it a classification problem or a regression problem?
It is a classification problem.
Okay. What is the size of the data set? What is the number of records in it?
A number of records is very less. It is actually, I got only 24 samples.
Then
But
deep learning will not give you good results, ma'am. Basically, deep learning is for the number. When I say size of the data, it's related to the number of records in the data. Or
Okay.
else, if you use a image data or video data, the volume again increases.
Okay.
But in genome data, if it is only concerned with the number of features, what you can try to do is, I've told you, I showed you, right? You can try doing this feature selection.
Yeah.
You can identify which feature has more predominant impact in improving the accuracy. You can
Okay.
determine that and try to choose those features while you build your model. So even with a simple, since the number of data is only, records is only 24, going with a deep learning model will only improve, increase the computational cost.
Okay, ma'am. So how can I use it for feature selection?
Feature selection, we have some methods like building by constructing correlation plots, and there is another method called as recursive feature engineering, backward elimination. These are some of the methods.
Is
Again,
it
feature
available
selection,
with the deep learning?
it's not. This is a part of data pre-processing, ma'am. Your feature selection. Basically, when you do feature engineering, you will select the features. It's
Okay,
not
so
the
is the
part of
code
building your
available?
model.
Ma'am, is the code explained before?
No, ma'am. In this session, we are not covering feature selection.
Okay.
It's a
Thank you.
separate domain.
Okay, thank you.
Ma'am, excuse me.
Yes, ma'am.
Ma'am, what about PCA, ma'am? For
PCA is a dimensional reduction work, ma'am. It's almost like a feature selection technique only. Okay. Here you try to reduce the dimension of your features. In the previous example, which the genomic data ma'am said, right? She will be having higher dimensional features. So yeah, even she can use PCA also. Basically, it tries to reduce the number of dimensions of the input features.
okay, ma'am, which is better actually, these methods or PCA?
Ma'am, in machine learning or AI, we cannot say which is better, ma'am. Everything depends on data. Your machine learning and artificial intelligence, everything revolves around data. So you have to first study your data. As I've told you, you have to play around with different algorithms to identify which is suitable for your data. We cannot say
Okay,
which
ma'am.
is better or which is the best. Nah, there is nothing like that in machine
Thank
learning.
you, ma'am.
Few
Thank you.
problems will work good for deep learning, but even with traditional logistic regression itself, I can even achieve 100% result for few problems. Then increasing the computational cost is not required by going with deep learning.
Thank you, ma'am.
Okay.
Hello, madam.
Yes, ma'am.
Now it is uploaded. Due to the network problem only, it is getting very slow uploaded, that files.
Okay.
That problem I faced. And another is in the runtime, it is showing 3 options, GPU, TPU, and none. So for this problem, we need to select the
None
CPU,
itself, ma'am. CPU.
none.
Yes, ma'am.
Oh,
See,
okay.
when you're working with image data or with video data, go with GPU or TPU, ma'am.
Okay.
Otherwise, for this one-dimensional data and all, with CPU itself, your computational will be good.
Okay. And
Okay.
when I'm running this program, it is asking for the option. This code is belong to this madam, and you need the permission like run away for this. Then I gave the
I have
command.
given edit access to everyone, ma'am.
So I need to resave it file. Otherwise, every time it is asking.
Make a copy, ma'am. Make a copy of the notebook in
Okay.
your local drive or in
Okay.
your Google Drive.
Okay, ma'am. Thank you. I'm new to this environment, madam.
Okay, not an issue, ma'am.
Ma'am, you just told that deep learning is required when we have a huge or big number of records. Am I right?
Yes, ma'am. Yes, sir.
And if we have less records, like say about in hundreds, like 150 records, then what should we go for, like machine learning or deep learning?
What kind of data is it, sir? Will it be a one-dimensional data as I have showed right now, or is it image or video or text
No,
data?
the data is like we have number of attributes in that, around 18 or
So it's similar to the wine data set we have seen, right?
yeah, definitely, yeah.
Okay. Then you don't have to go with deep learning. If the number of records is less, first try with the identify what is the problem type, whether you're going to do classification. That is, what is the class label you're going to identify? Is it a classification problem or is it a regression problem? Okay. Then related to classification or regression, choose the machine learning algorithm. Okay, if it is classification, you can first start with logistic regression itself.
It will be actually some prediction, short-term or long-term prediction.
That's what, sir. What will be the target variable? Will it be a continuous data or a discrete data?
Okay. So
Okay.
I think
if it is a discrete data, then you can do classification related algorithms. Your logistic regression is a classification algorithm. Whereas if it is a continuous data, as I told you, for housing sale prediction and all, the price will be a continuous data, right? If it is a continuous data, then you have to go with linear regression or any other regression models. Okay.
Yeah, okay, ma'am. Thank you so much.
Yes, sir.
Any other questions from participants?
Thank you, madam. Thank you.
Thank you,
ma'am.
Thank you, Dr. A. Alice Nithya, ma'am. So it was a great pleasure listening to about introduction to deep learning architecture. It was from scratch to progress. We loved the real-time examples that you shared. Thank you, ma'am. Participants, now it's time for a lunch break. I request all the guests and participants to join us for the third section for today at 2 p.m. sharply. Thank you.